Now let's try to see how many antisymmetric relations are possible on a set A with n elements. Okay, so the basic assumption is this one always. So the number of elements in set A is n, and we know that the number of elements in A cross A, the number of order pairs will be n square. Now I want to find out, using these n square elements, how many relations can we make in such a way that they are antisymmetric. Okay, so first of all, let me take a small example and show you with that. Let us say A equal to 1 2 3, which means it is a set containing 3 elements. With this I'll show you. Then what about A cross A? Then we know that A cross A is going to contain 1 comma 1, 2 comma 2 and 3 comma 3, and then the non-diagonal elements are present. What are they? 1 2, 2 1, 2 3, 3 2, right, and then 1 3, 3 1. These are the non-diagonal elements, right? These are the diagonal elements and remaining are the non-diagonal elements, which means this one and this one. These are the non-diagonal elements, right? Okay, now using this, how many relations can I form in such a way that they are antisymmetric? So first thing is, for sure, if you try to use this diagonal element, you may or may not use it in forming the antisymmetric relation, and so it is going to give two cases, right? Which means you may use it and form an antisymmetric relation, or you may not use it and still form an antisymmetric relation. And similarly, this one also will give us two cases, isn't it? 2 into 2, and again this one also gives us two cases. Fine. But then coming to this one, now I cannot talk to them as individual pairs. I can talk about this pair together. Okay, so if you take this pair, either you can include 1 comma 2 and make a antisymmetric relation, or you can include 2 comma 1 and make a antisymmetric relation, or you need not include both of these, none of these. Got it? Therefore each pair is going to give us three cases. Either you include first one or second one or none of them, right? And similarly this pair is also going to give us three cases. This pair is also going to give us three cases, 3 into 3 into 3. Got it? So how did we get it? Now what is the answer? 2 power 3 into 3 power 3, right? So how did we get this? All the diagonal elements are going to give us two cases, and the remaining non-diagonal elements, when I pair them up, each pair is going to give us three cases. Got it? Therefore it is 2 power 3 into 3 power 3. Now what does this 2 power this number represent? Number of diagonal elements. And what does this 3 power this number represent? Number of non-diagonal pairs, right? So in case if you have A equal to n, right, then A cross A will have many elements, not just 9 elements like this. It will have n square elements. Now what are all they? 1 comma 1, 2 comma 2, 3 comma 3, so on, n comma n. These are all the diagonal elements, and then we have non-diagonal pairs like this, 1 comma 2, 2 comma 1, right? We have non-diagonal pairs like this. Okay, now all these are going to give us 2 power n cases. Just now we have seen it. And now the remaining elements, how many remaining elements will be there? How many pairs will be there? It is n into n minus 1 by 2. We have been seeing this for a long time, isn't it? These many pairs will be there. So 3 power n into n minus 1 by 2. So this is the answer. The number of antisymmetric relations possible on a set with n elements is 2 power n, which is n is nothing but diagonal elements, into 3 power n into n minus 1 by 2. This is nothing but the non-diagonal element pairs. So this is the total of, and this is total antisymmetric relations possible. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.